Hello students, welcome back. We completed section 1. Now let's go to section 2, radical equations. Now this is going to be hard and this is going to be new to pretty much everybody. The basic structure is like this. The nth radical of an x expression is equal to another x expression. How to solve it? Take the nth power of both so that we get green equation with no radical. The original equation is highlighted in blue. The green equation is highlighted in the second equation is highlighted in green, and that's what we call the derived equation. They're related, but they're not the same. So this blue and green are not twins. They may be brothers, maybe sisters, or maybe cousins, but they're not twins. They're not the same. Not always the same. And consequently things can differ. Solutions of this original blue must be solutions of this green. That's true, but not always vice versa. There may be some solutions of this green derived equation that are not solutions of the original. Those kind of solutions are called extraneous solutions, and we have to screen those out. But I don't like the term extraneous. Outside math classroom, you never use that kind of term. Invalid solution or fake solution, illegitimate solution. I prefer those kind of terms. Okay, let's go ahead with an example problem, and this first problem is going to be pretty benign. Why? Well, we have just one radical, and then outside we don't have any other x expression, just constant. So it's easy. Isolate the radical and take the third power of both sides, and then you get very easy equation. So we have, no need for that, copy and paste this thing. Okay, flip this 2 to the other side. There you go. And then cubing root of both sides. So take the cubic root, cubic power of this cubic root, and what do we get? Cubic power and cubic root cancel each other out, so we get 2x minus 4 on the left hand side. Right hand side, 2 to the third power is 8. 2 times 2 times 2. And all of a sudden we have very easy equation to solve. 2x equals to 12. X is 6, and I claim this is my solution. And do not just abandon here, put it back into the original equation and check, is this legitimate? I'll leave the detail to you. Here, let me show you the answer key. Yep, we got the same computation and the same answer, and then here's the checking process. It works out. 2 times 6 is 12. 12 minus 4 is 8. So we get cubing root of 8. That's equal to 2. So it works out okay. How about the next problem here? Well, stop the playback and then work it out. Same type of problem. Isolate the square root and square both sides. Did you get it? Let's put some space in between. Okay, alright. And then isolate the square root. So flip this 3 to the other side. 1 minus 3, we get negative 2. Well, we get that. And I could take square of both sides, but looks like there is a simplification going on, so let's do that first. Divide by negative 2, and we get 1, and we get positive 2. I'm going to square both sides, so positive or negative, that doesn't matter too much, but reducing the number is always welcome. So, okay, alright, and I'm going to square both sides. So this thing squared, and then this thing 1 squared. So what do you get? 2 squared is 4, and then times 3x plus 1, and that's 1 squared, it's 1. Alright, that's easy. 12x plus 4 equals to 1. 12x equals negative 3. So I'm getting x is, I don't need that. X is negative 3 over 12. It'll simplify it into negative 1/4. And then you can check for possible illegitimate solution. Put it back into the original equation and check. Does it work out? It'll turn out to be yes, but that part is left to the students. Please check. I'll show you the answer key. Same computation, same answer. Well, okay, alright, I didn't simplify, so I paid a price, bigger number, hard to calculate. But in the end, yeah, it turns out okay. Next. Okay, this is going to be harder. I can immediately see that this is a hard problem because there are x expressions outside the square root as well. Put some space in between and then bigger font. Alright, isolate the square root. How do I do that? Step 1, denominator. Let's remove this denominator to the other side. Multiply by 5. 4 plus 3 square root of 2x squared plus 3x minus 1. And then multiply by 5. So what do you get? 5 times 3, 15x. Multiply by 5. Did I do this right? And then I want to isolate the square root, so flip this 4 to the other side. We're gonna get, let me copy and paste this entire thing, and then flip this 4 to the other side, subtract it away, and 5 minus 4, we get 9. Do you like this? All good? Ready to go? Square both sides? Not quite. I'd like to simplify further. Everything here is divisible by 3, so let me simplify further. Divide each term by 3. The square root term divide by 3, so that's gone. 15 divided by 3, so we have 5. 9 divided by 3, you have 3. Okay, there goes the simplification. No need for further division here inside. We already have division by 3 already done to this entire term. You see, this is not addition, this is multiplication. So divide away, 3 is gone, and that's it. Now I'm ready to take square of both sides. So square this, and then square this. Okay, left hand side, radical and square will be gone. That's the idea. Square root and square, cubing root and cube, quarting root and fourth power, cancelling out. And to the right, well, you can do 4x minus 3 and then 5x minus 3 and then FOIL out. You can do that, or you can use the complete square formula as I'm doing right now. Ax squared, so 25 x squared, squaring the first term, and then twice of 5 times 3, so that's 30x, and square 3, so we get this by complete square formula. That's handy. I prefer to use complete square formula over just foiling out whenever I have square. In solving that, okay, let's go ahead and solve it. 25 minus 2, so 23x squared and then flip 3 to the other side. 33x and then plus 10 equal to 0. How do I factor this? Or should I use quadratic formula? It turns out you can factor it. 23 plus 10 is 33, so you can easily factor it actually. 23x and then minus 10 x minus 1 equal to 0 like this. 23 times negative 1 is negative 23. Negative 10 times 1, so negative 10, so they add up to negative 33. If you're unsure, you can set up tic-tac-toe or whatever. In any case, we have this red factor times blue factor is 0. So one of them has to be 0. So 23, what am I doing? Okay, sorry about the typo. So from the first factor, x is 10 over 23. From the second factor, x is 1. Is that clear to you? That's coming from red, and this is coming from blue. 10 over 23, and this is negative, so we have sign change, positive. This one is straightforward, 1 over 1, we have sign change, so positive 1. If you're not sure, you may have to do it this way. 23x minus 10 equal to 0. 23x is equal to 10. Flipping, change the sign. X is 10 over 23 like this. And you can do the same thing for the other as well. But it's okay to skip steps like this. So what do we have? We have these two solutions. But are they really solutions? How do I know until I go back to this original equation and check? So you have to go back and check. Plug in x equals to 1 and check. Plug in x equals 10/23 and check. And for the latter, you really need a calculator for that. I'm going to leave the detail to you. I'll just show you the answer key. And the answer key says, isolate the radical and square both sides and solve the resulting quadratic equation 10/23 or 1, and we are not done yet. If you plug in and do your computation, it turns out x equal to 1 is a solution. Oh, sorry about this typo. It should be positive 10/23. In this case, it's invalid. Doesn't work. Here's Mathematical's verification, and left hand side minus right hand side after plugging 1 turned out to be 0. You see, this minus right hand side, I did this computation and turned out to be 0. And then in this case, same computation, left minus right. That's not 0, something else. So that's invalid. And if you use Mathematica to check, then it finds only one solution, x equals to 1. And those are computer solution, and it fits all this computation. What do you think? Can you reproduce this kind of solution if I write this kind of problem in the exam? Or do you just have to hope that I don't write a lot of problems like that? Well, I'm not going to blame you if you are the latter type, because this is a hard problem. But I'm afraid even harder problems are showing up in the next video.